Welcome to this presentation on rubbing velocity in pin joints. Today we'll explore how relative motion between connected mechanical links affects wear and performance in rotating systems. Whether you're studying mechanical design or working with machinery, understanding rubbing velocity is crucial for optimizing joints durability. Pin joints are fundamental in mechanisms like engines, robotic arms, and linkages. When two links rotate relative to each other, friction at the joint causes wear, quantified by rubbing velocity. In this presentation, we'll define key terms, derive the rubbing velocity formula, and discuss its real-world implications. So here we see two links, OA and OB, connected by a pin joint at point O. Link OA rotates at angular velocity omega 1, while OB rotates at angular velocity omega 2. The pin has a radius of r. The relative motion between the two links determines the rubbing velocity, which we'll calculate next. Now, rubbing velocity is a tangential velocity of a point on one surface relative to a point on another surface in contact with it. It's a measure of how quickly two surfaces are sliding or rubbing against each other. Angular velocity omega measures how fast a link rotates relative to the pin joint. For example, omega 1 is the speed of link OA relative to point O. Rubbing velocity is the relative surface speed at the joint, directly linked to wear and heat generation. The rubbing velocity depends on rotation direction. If both links rotate the same way, their velocities partially cancel. So here we are saying rubbing velocity at the pin joint O is given by omega 1 minus omega 2 multiplied by r if the links move in the same direction. Then rubbing velocity at pin joint O is equals to omega 1 plus omega 2 multiplied by r if the links move in the opposite direction. Higher rubbing velocity means more friction, wear, and heat. Engineers combat this by selecting hardened materials like alloy steels or using lubrication. For instance, in car engines, pistons endure high rubbing velocities requiring precise design to avoid premature failure.